All right, so the warm-up was to find the domain of, and then the function has an x minus 2 on top. There's an x and an x minus 2 on the bottom, and a radical term. Oops. So x minus 2, and this thing. Okay, so you probably wrote down some facts. There's really kind of two things going on at the same time. One is you can't divide by 0, so you maybe wrote down some exclusions. For example, x cannot be what? What'd you guys put? 0, right? X cannot be 2. X cannot be 3. X cannot be negative 3. All of these cause you to divide by 0.
And then x is greater than negative 3, and x is less than 3.
Okay, so yeah, we do have to look at this radicand. Okay, the inside of the radical has to be, typically we say it has to be greater than or equal to 0. Right? That's the rule. That's sort of the other rule. So 9 minus x squared has to be greater than or equal to 0. Since it's a radical on the bottom, we have to go one step further and say we can't even allow it to be 0 because then we have square root of 0. So we're going to just make it 9 minus x squared is greater than 0 and try to solve that. So how do you solve this?
X is less than 3, and x is greater than negative 3.
Yes, that's right. So one way to do this is to factor it like this. You go 3 plus x, 3 minus x. And just ask yourself, what are the roots? So that'd be negative 3 and positive 3. And then what you do is you test a number, one from the left, one from the middle, and one from the right. This is how you learned it in Algebra 2. So you can test like x equals negative 10, test x equals 0, which is in between, and x equals 10, which is on the right. And it turns out if you plug in these numbers, you get false, true, false. So I'll do it real quick. But you're trying to do basically 9 minus x squared. So it goes 9 minus negative 10 squared. Is this greater than 0? The answer is no. It's not. So you would not shade. Is 9 minus 0 squared greater than 0? Yes. So you would shade here. Is 9 minus 10 squared greater than 0? The answer is no. So it's false. You do not shade to the right of 3. So you've basically decided that square root of 9 minus x squared, that requires us to have a number between negative 3 and positive 3. And because on the bottom we can't include the endpoints. Okay, so we have to make sense of this answer completely. So we have a red answer and we have a blue answer, and we have to put them together into one meaningful answer. Okay, so let's do that. So the final conclusion is the domain of f is the set of all x's such that, and then we have basically the rule, x has to be something between negative 3 and 3, but it cannot be 0 and it cannot be 2. Okay? All right, let's also draw a number line of our domain. So this would be a domain number line. The domain number line would look like this. I'll take anything that is between negative 3 and positive 3, just not 0 and 2. So you could draw your answer if you like this. Something like that. Or you could write your answer in interval notation. We have that option now. That's new for this year. We can write basically that x is any number between negative 3 and 0. Combine that with all numbers between 0 and 2. Combine that with all numbers between 2 and 3. That's the interval notation that we learned earlier in the videos that we were watching. And the round parentheses mean without endpoints. So we don't include the endpoints. So which notation's best? Both. They're both important. I cannot tell you which one's best because on my test there's some of this and some of that, there's some of that and some of this. It's just the questions have it, the answers that you write. I might ask you to do interval notation. I might ask you to write inequalities. Okay? So you want to be comfortable with both systems. Did anyone get this answer exactly right? Okay. So I think we're getting closer to the point where domain problems are not just like guess and check. Okay? Because back in Algebra 2, the teacher would say, tell me what values are forbidden. And you'd be like, 3, 5, 2. And that was the end of the problem. It's not quite that simple anymore. Okay, you kind of have to show a little work to really get it right. And as we see today with composite functions, that's even more true. So, all right, I'm going to pause it for a second. Okay, so today we're just doing the second part of that lesson. So the title of the section is Operations on Functions and Composites. But we've already done the first part, so it's just composites today. And there was a sentence you wrote down yesterday, hopefully you wrote it down, that said the domain of FOG, or FOG I've been calling it, is the set of all x in the domain of G such that G of x is in the domain of F. What in the world does that mean? Okay, so the domain of FOG is probably one of the harder things to figure out in this class. Okay, there's a few sections in this book that are tough, and this is one of them. So what is the domain of FOG? If you just read that sentence, you got to really pick it apart to understand it. It's saying that it's all the x's that are in the domain of G, so that's one criteria. And G of x has to be in the domain of F. What does that even mean? So I wrote it in my own words here underneath. I put, in other words, the excluded values of a composite consists of all real numbers that cause the inner function to be undefined, or cause the inner function to output values that make the outer function undefined. It's a mouthful too, but if you read it carefully, you can understand it maybe. Here's basically what it's saying. Let's say there are two functions, right? F of G, and you were going to try to find the domain of FOG. So you go up to G and you say, hey, you're going to be the input function, okay? All right, G, you're going to be the input function. So I'm going to give you a number, and then you're going to find an output, and then you're going to take that output over to your friend F there, and give it to him. And he'll receive it as an input. And G's going to say, well, hold on, I have rules. You can't just give me any number. So you say, okay, so you're talking to G. You say, G, what can you accept? G says, I'll take basically any numbers except 4. And 7. Don't give me 7. I don't like 4 and 7. I don't know what to do with them. They make me undefined. So you're like, fine. I won't give you 4 and 7. So you give G all the numbers besides 4 and 7. G is happy. G goes and finds outputs for every number you gave him. Okay? Takes those outputs to F and says, I'm going to give you some numbers. And F says, whoa, hold on. I have rules. I don't like 10. Don't give me 10. And G's like, ah, shoot, that was one of my outputs. Well, okay, I won't give you 10. Here's the rest of it. In the end of this problem, the only numbers that can be accepted, or the only numbers that can be accepted by the whole system here, is the numbers that G accepts and the outputs of G that F will accept. See? That's the idea. So it's kind of a complicated idea. So I'm going to try really hard to make it not dumbed down, but step by step. Okay? So let's give it a try. Here's our first example. Here's your functions, f and g. We're going to be studying, hold on, I think that's example 2. Where's my example 1? There it is. F and g. And we're going to do fog. fog. Okay, so here's how I do these problems. First thing I do is I write down what fog means. So fog means f of g of x, right? And then I identify the inner function, the inner as opposed to the outer function, okay? So the inner function is clearly g. I'm going to write down its domain right now. Okay, so the domain of g of x is, and I'll just abbreviate. Let's just write down the exclusion. What will g not accept? G is the function 4 over x minus 1. So what is the value of x that g forbids? 1. It will not take 1. Fine. Okay, this is part of your answer, your final answer. Part of final answer. We're a little less than halfway done. So this is phase 1. Look at the input function, inner function, and ask what is the domain. Okay, let's go on to phase 2 of the problem. The next thing we do is we write down what f of g actually means, like analytically. It means, instead of 1 over x plus 2, it really means 1 over g of x plus 2. That's what it means. Fog means 1 over g of x plus 2. As soon as I wrote that, I suddenly realized something else. G of x cannot be, look at this picture. G of x cannot be what? Negative 2. I didn't know it until I wrote this, but I realize it now. So I'm going to write what I just thought. Note that g of x cannot be negative 2. Interesting. Let's pursue that thought. So g of x cannot be negative 2. G of x is this function right here. It's 4 over x minus 1. So what we're saying is 4 over x minus 1 cannot yield negative 2, or f won't accept it. See? If we solve that, we'll be done with the problem. Okay, it's kind of weird working with a not equal symbol, but just think of it as an equal sign. Cross multiply this, and you get 4 is not equal to negative 2x plus 2. Subtract 2, divide by negative 2. We learned that x cannot equal negative 1. That's the end of the problem. This is the other part of your answer, the rest of your answer. So it's a two-stage ordeal. You first ask, what is that inner function, and you write down its exclusions. That's easy. Then you go back and you say, all right, what does f of x, or what does f of g of x look like? After you jot it down, you suddenly realize, oh wow, I can't let g of x be negative 2. And then you pursue that thought to find more restrictions. Okay, now the answer is a little surprising. There's two things that are surprising about the answer. One, I would have thought that x equals negative 2 was forbidden. Look at the problem. Wouldn't you have thought that x equals negative 2 would be forbidden from this problem? F does forbid that. But it is not forbidden in this problem. Because we're not evaluating f, we're evaluating f of g. F of g is perfectly content with negative 2. There's nothing wrong with negative 2. So that might be really hard to understand. But if you follow my steps, you could get the problem right. What did I do? I wrote down what fog means. I identified the inner function. I found the domain. I'm half done. I did not look at the outer function there. Then I wrote down what f of g means analytically. It's 1 over g of x plus 2. I then noted that g of x cannot be negative 2. And I pursued that thought, and I learned that negative 1 is forbidden. Here's the other thing that's surprising. When you look at the original problem, it does not appear that negative 1 is forbidden. Look. If you're into domain guessing check, if you play that game, and you've been doing that for a while, you're going to be really frustrated with this problem. There's nothing about this problem that would make it seem at first that x equals negative 1 is forbidden. Why is negative 1 forbidden? Well, the problem with negative 1 is it causes this to be negative 2, which then defies f. See? So try to follow my stages. Let's try Goff now. So same exact functions. Let's just write it as part B, find domain of Goff. Same two functions. Okay, so what did I do first? Remember? I wrote down what Goff means, right? So I wrote, Goff means this. I identified the inner function. So what is it this time? Yeah, f of x. And the domain of f of x is clearly what? X is not 1. Correct. No, that was the domain of g. It's negative 2 that's forbidden from f. Okay, you're half done. You can circle that because that's part of your answer later. All right, stage 2. Now write down g of f of x as an expression. So instead of 4 over x minus 1, it's 4 over f of x minus 1. Suddenly you realize that we have another restriction. F of x cannot equal what? 1. It's obvious once we write it. Not so obvious before we wrote it. Okay, so note f of x cannot equal 1. So if you're thinking that, then you might as well write it. And if you're writing it, you might as well flesh it out. So let's change f of x now to 1 over x plus 2. And solve that. So this gives me that 1 cannot equal x plus 2. X cannot equal negative 1. This is the second half of my answer. Okay, so let's just write our final result here. The domain of Goff is all the x's except for what? Negative 2 and negative 1. That was my conclusion on this problem. So you can't tell by looking at the original problem. You have to actually compose it and look again. Yeah?
Would negative 2 be excluded because it would make 1 over x plus, it would make,
Negative 2 was excluded because the inner function won't take it. And if the inner function is undefined, then he'll never walk over to the outer function to plug himself in. See? It's not going to happen. So you have to satisfy the inner function. Then the inner function has to produce outputs that make the outer function happy, because those are going to be the inputs. So what's surprising on this problem is that x equals 1 is perfectly okay. On this problem. X equals 1 is perfectly okay. It does not cause any undefineds when you evaluate f of g. Weird. Okay, let's go to the next question, which is FOF. Same exact functions, but we're doing FOF. FOF means f of f. So forget about g for this part of the problem. We're composing f with itself and talking about the domain. See what you can do with this one, and then we'll regroup. I'll pause the video. Okay, so obviously f of f just means f of x. So the inner function is f, the outer function is f. Okay, so I'm going to write that. I'm doing all my examples the exact same way. Inner function is f of x. The domain is x cannot be negative 2. Okay, circle it. It's part of your answer. Phase 2, write down what f of f means. It means 1 over, not x plus 2, f of x plus 2. You suddenly realize that f of x cannot equal what? Negative 2. You then pursue that thought by writing, I meant to write cannot equal. So f of x cannot equal negative 2. Then you write 1 over x plus 2 cannot equal negative 2. What did you guys end up getting for this one?
X cannot equal 5 over 2.
Yeah, x cannot be negative 5 halves. So unless you're really sharp, okay, you probably would never get that second answer. Right? I mean, unless you really can do that in your head, which is fine if you can, but you really need some method, you know? I think gone are the days where you guess at the domain, because you're not going to get all the right restrictions. We could do GOG as well, but we're not going to. Let's look at different function pairs. So I already did f of g, the same two functions over and over. What would happen if we switched it up? So see, this particular problem, the fog is probably all we can handle. If you try to find the domain of Goff, I'm pretty sure most of you get pretty stuck, okay, because it gets pretty ugly. So let's just try fog only on this one. Okay, so fog means f of g of x. So what's the inner function? Yes, g of x. What is the domain of the g of x? You have to maintain that 4 minus x is greater than or equal to 0, right? That's the rule. Okay, so you would conclude that this is the first half of your answer. This makes g happy. Okay, so if you give numbers 4 or less, g is happy. Now let's take that and see what it looks like on the composition. Yeah. Question?
No.
Okay. So phase 2 of the problem, you take that f of g statement and you write it as 3 over, not x times x minus 2, but g of x times g of x minus 2 is what it means. So as soon as I write this, I realize, wow, we got some more rules here, don't we? What do I got? G of x cannot be, right, so g of x better not be 0, right? And also, g of x better not be 2. Both of these would give us problems with that composition. Okay, so let's pursue those. We are saying that we don't want root 4 minus x, I keep writing equals, I mean not equals. We don't want root 4 minus x to be 0, and we don't want root 4 minus x to be 2 either. See? So we got to pursue both of these. What's the first one telling us?
X cannot equal 4.
Yeah, there's only one root to this. If you solve this, you get 4 minus x cannot be 0. Okay, so there's exactly one thing x cannot be, and that is 4, right there. And this other one, we square that, and we get 4 minus x cannot be 4. This reminds us that x cannot be 0. Okay, so we have a little bit of a contradiction. In phase 1, we had decided that x can be only numbers less than or equal to 4. In phase 2, we said, no, x can't be 4, nor 0. So how do you combine the ideas that x is less than or equal to 4 and x is not 4? How can you combine those two? X is strictly less than 4. But we also have the rule that x can't be 0. So let's write our answer. Domain of fog is all x's such that x is less than 4 but not 0. Yes?
So the composite function, if both functions are all real numbers, then in that case, no matter how you do it, it would all be, the domain would just be
Yeah, I'm a little frustrated with some of the homework problems. Like if you look at the text, right? Number 31, number 33, number 35, those three problems, honestly, the two functions they give you are both polynomials, which means they'll accept any number. So you can basically give G any number. G will output a number, take it over to F, and F will say, fine, give it to me. And nobody has any rules, and it's like America these days. Well, that's right, anarchy. Okay, so anyway, it's the way people act. The laws are strict in our land, but people don't abide by it. So basically we have all real numbers, all real numbers, all real numbers on some of these homeworks. It's frustrating. So if you want to blaze through 31, 33, 35, get to the good ones. 37 is really good. 39 is really good. 41. By the way, on this problem, we can't really do Goff, I mentioned, because you get to a point where you kind of freeze and you don't know maybe how to solve those kinds of problems yet. If you want to try that one for bonus tonight, I'll give you bonus points. First one to submit it to me tomorrow with the correct domain for Goff. That's for example 4. Okay? I'll give you bonus. Okay, and then this is also in your homework. This is not a hard problem at all. It's just basically a shift in topics. They're just saying, look, let's find fog and Goff, and let's show that both of them just turn out to be X. Okay, so let's try this problem. This is really a lot simpler. Okay, let's work on fog real quick. So this just means f of g of x. F of g of x would basically be, it would have the appearance of f, but it would have g as its input. So it would look like this. That's what it would look like. That's f of g. Well, what happens is you multiply 3 times a third, and this cancels out. And you're left with x plus 4 minus 4, which is, as they said, equal to x. They asked us to show that f of g was going to turn out to equal x, and we just did. Now let's do Goff and see if it also comes out to be just x in the end. Okay, so let's find Goff. That means g of f of x. This has the appearance of g, but for its input, we have the f function. This time it's the 4's that cancel first, and we get 1/3 of 3x, which is x, and we done did it. We showed that f o g and g o f are both x. Does anyone remember what this means from the Algebra 2 days? What does it mean when a function's composed with another function yields x? Somebody said inverse. Yes. So what's going on is, you can understand it this way. If you find f of g of 10, the answer is going to be 10. So you give 10 to g, right? And g says, oh, I'll do something with that. Let's say g takes that number and multiplies it by 15, takes away 20, multiplies it by 2/3, raises it to the 3rd power, and then, I don't know, cube roots it. Something. I guess raising it to the 3rd power and then cube rooting it is kind of unnecessary. But my point is g does something to the 10, right? Takes the answer, gives it to f. F says, all right, let me have that thing. Takes that number, messes around with it, and out pops the original number that was given. So what's going on is f and g are basically opposite operations. So whatever g did to the number, f just undid all of it. You see? So we call that inverses. And if you look back at this problem, it makes perfect sense. What is f's job? F's job is to triple the number and take away 4. And what is g's job? To add 4 to the number and then take 1/3. Their jobs are complete opposites. They have opposite function rules. So it's like a guy digging a hole, right? And there's someone standing right behind him filling it in. That's what's going on. This will work with any number. It says this came out to x, we didn't even say what x was. So x could be 10, x could be 100, x could be pi. Whatever you put in is what you're going to get out. So we'll talk more about inverses later, but this is foreshadowing that idea. Okay.